While we are on this page, let's talk about the light falloff as well. The light falloff is the effect of dimming of the light source depending on whether it's positioned close to the subject or further away. I mean, what would be the difference if we have pushed our main light further away into the background and compensated the size and the intensity? By the way, I'm utilizing the math expression within the power tab, multiplying by 50. Okay, we have pushed the key light further away and compensated the rest of its properties, but there is something going on with the light gradient, with the way, let's say, the light travels across the table. Compared to when the light was much closer, the light gradient on the table is not as prominent, and I would also say not as visually pleasing, although it is hard to put finger on what exactly has changed. We will need a better example for that in just a moment. Okay, let's Ctrl Z a few times to bring back the old position of the light source, where it was way closer to the minerals, before actually evaluating the comparison shot. I wonder, can you tell what has actually changed in between these two positions of the key light? What difference has the distance brought into this equation? Have a look at these two images. In one of these, the light was placed further away, with the power and the size adjusted accordingly, and in the right one, on the contrary, the light was placed as tight as possible to the subject. You know what, let's have a look at the better example. Because the area light is way closer to the first sphere than to the last one, the first sphere receives more light. It's the effect of more rays hitting its surface, so as a result it's better exposed. You can clearly tell the difference in exposures, in between the spheres and on the floor for that matter. As if the light gets dimmer as it travels across the floor, which is not true obviously. The gradient of light and dark is simply a byproduct of more or less rays hitting a certain portion of the object. The sphere that is close by to the light source receives more rays than the sphere that is furthest away from the light source. And that's it, that's the light falloff in a nutshell. Let's compare this light placement with the one in which our key light is moved much further away. Again, with retaining the power, with compensating the power and the size. Now the intriguing thing had happened. Look how flat is the lighting across the entirety of our objects and surfaces. There is practically no difference in exposures anymore in between four spheres and in between the near and far points on the floor, as if changing the distance in between the light source and the subject somehow unified the lighting across the scene. It is especially evident when juxtaposed with the first example, where light was essentially very close. So the relative distance in between the light and the subject and the background really matters. So I guess a takeaway tip is this. Keep your light source close if you want to play with the light falloff effect.